in your house? Well, it is in mine. Wouldn't it be nice if you could just change the color of your house and become warmer or cooler? Well, that's what I wanted to find out from my science experiment.
I think this will help Hawaiians make their houses cooler. They could really use these results. Hawaii needs these results.
Can color help you keep your cool? In this science fair project, I wanted to find out if when you paint your house a certain color, if it would make your house warmer or cooler. My hypothesis was that the color of the house would make a small but measurable difference, and the darker colors would absorb more heat than the brighter colors. The controlled variables in my experiment were the house, simulated sun exposure, and the way I measured the temperature. The independent variable, the thing I changed, was the roof/siding colors of the house. The dependent variable, the thing I measured, is the temperature increase over a period of time. Materials: timer, house, thermometer, lights, roof/siding colors, and laptop. To do this experiment, I made a house frame and mounted a thermometer on the front of the house with the sensor inside the house so that I could measure the temperature inside the house. Then I folded colored tops/sides appropriately and measured the temperature differences and took pictures of the time and temperature with my computer. Now for the pictures. Me sitting with my recording notebook and doing my experiment. My laptop showing one of the photos I took with it. My experiment setup. Me observing my experiment in progress. This is the data in numbers, but it's easier to compare when looking at a graph, so let's move on. This is my trial 1 graph, which was over a period of 15 minutes. Measurements were taken at 1-minute intervals. As you can see, infrared black absorbed the most heat, while the aluminum foil reflected the most heat. The construction paper stayed in the same clump, but it was easy to tell which one increased more. This is my trial 2 graph, which was over a period of an hour, with data taken at 5-minute intervals. The reason it's over a longer period of time was because I wanted to see if the temperature changes would continue over time, or if they would do something different. Infrared black was still absorbing the most light, while aluminum foil was still reflecting the most light. Construction paper colors weren't in the same order and therefore are inconsistent. This is my trial 3 graph, which was over a period of 15 minutes, with measurements taken at 1-minute intervals. Near-infrared black and foil were the same, but the construction paper colors, yet again, had changed their order and are therefore very inconsistent. Originally, I didn't have near-infrared black. Here's why I added it. The construction paper colors were inconsistent. I wanted to find out why, so I took a picture of them in near-infrared, and they all looked like the same shade of gray. So I looked for something that would turn up black in there, and I found this black insulator's craft foam, so I ended up adding it to the experiment. Conclusions. My experiment does not support my hypothesis. Visible color does not make a measurable difference, like I thought it would. Aluminum foil keeps it cool. Near-infrared black absorbs twice as much heat as any other material I tested. This experiment can be used in the real world to find what color to paint your house.